Welcome to the fastest way to learn data structures and algorithms. Today, we are mastering LeetCode 5, the longest palindromic substring challenge. This is a classic string problem that appears in almost every top tech interview. If you can expand from the center with confidence, you unlock a pattern that solves dozens of palindrome problems. Given a string S, return the longest substring that reads the same forward and backward. A palindrome mirrors itself, like racecar or ABA. For example, if S equals Babbitt, the answer can be Bab or ABA, because both are length 3 and fully symmetric. If S equals CBBD, the answer is BB. Think of each character in the string as a stone dropped into a perfectly still pond. The ripples expand outward, left and right, as long as the water on both sides stays identical. The moment one side reflects a different letter, the ripples stop. Every drop creates its own ripple pattern, and we simply keep the widest mirror we find before moving to the next stone. We use the expand around center approach. Every palindrome has a center, either a single character for odd lengths or the gap between two characters for even lengths. For each index I, we expand twice, once for the odd case at I, and once for the even case at I plus 1. We track the longest span with start and end pointers. When a longer palindrome appears, we update those bounds and continue scanning. Let us dive into the dry run. On screen, our input string is B, A, D. Our goal is to find the longest mirror substring. We keep a tracker for start, end, and the current best length. We begin at center index 1, the letter A, odd case. Left and right both sit on A. They match, so we expand outward. Left moves to index 0, B. Right moves to index 2, B equals B, so we expand again. Left would go to -1, so we stop. The palindrome length is 3, covering indices 0 through 2, which spells Bab. We update our best result to Bab. Next, we move to center index 2, the letter B, odd case. Left and right start on B. We expand to index 1, A, and index 3, A. They match. We expand again to index 0, B, and index 4, D. A B does not equal D, so expansion stops. The palindrome length is 3, indices 1 through 3, which spells ABA. It ties our current best length of 3. We finish scanning all centers. The longest palindrome length is 3, and we return Bab from start 0 to end 2. In Python, we define a helper expand function that takes left and right pointers. While both pointers stay in bounds and the characters match, we move left down and right up. When the loop stops, we return the palindrome length as right minus left minus 1. In longest palindrome, we loop I across the string, call expand for odd and even centers, and update start and end whenever we beat the current maximum length. Finally, we return the slice from start to n plus 1. Time complexity is O of n squared in the worst case, because each of the n centers can expand up to n steps. Space complexity is O of 1, since we only store a few index variables and never build a new string during the search. And that is the longest palindromic substring challenge mastered. The expand around center pattern is one of the highest value string tricks in interviews. Save this video for your next technical interview, and follow Leo Academy for more premium DSA guides.